All right, hey AP Stats folks, this is Mrs. Miller. This is my first video, so we will see how this goes. Our first example, we are in section 10.2, so we are talking about comparing two means. So in 10.1, we talked about comparing two proportions, and today we're going to be talking about comparing two means. So just like last chapter, or last section, we started with talking about the sampling distribution. So we choose a simple random sample of size n sub 1 from a population 1 with a mean of mu sub 1 and a standard deviation of sigma sub 1, and then an independent simple random sample of size n sub 2 from a separate population with a mean of mu sub 2 and a standard deviation of sigma sub 2. When you want to describe your sampling distribution of the difference of your means, you want to talk about three things: your shape, your center, and your spread. Our shape will be approximately normal in one of two cases. When the population distributions, both of them, are normal, then the distribution of the sampling distribution will be normal. Unless, so in which case we need to check if it's not normal for the population, we need to look at the sample sizes. And each sample size needs to be at least 30, right? That's our central limit theorem kicking in there. The center is going to be the difference of our population means. And our spread, our standard deviation of the sampling distribution, is going to be this cute little formula right here. So it's our standard deviations squared. Note that they're squared over their separate sample sizes. And we still need to check our 10% condition to make sure that that is being met. Okay? So we're going to go to our first example. And I'm going to switch gears here and go to this guy. So, looking at our first example, based on information from the U.S. National Health and Nutrition Examination Survey, the heights of 10-year-old girls follow a normal distribution with a mean of 56.4 inches and a standard deviation of 2.7 inches. So those are important pieces of information, the means and the standard deviations for the females. And then it says the height of 10-year-old boys also follow a normal distribution with the mean of 55.7 inches, standard deviation of 3.8 inches. A researcher takes a random sample of 12 10-year-old girls and a separate sample of 8 10-year-old boys in the United States. After analyzing data, the researcher reports that the mean height of boys is larger than the mean height of the girls. So, first thing we want to do is we want to describe the shape, center, and spread of the sampling distribution for the difference between the mean of the females minus the mean of the males. So my shape, because it told me that both of our populations are normally distributed, we know that the sampling distribution is also going to be normally distributed. Okay? So we can say that the sampling distribution of x bar sub f minus x bar sub m is normal because both population distributions are normal. So that takes care of our shape. Now we need to talk about our center. When we're talking about center, when it comes to distributions that are normal, whether it be a sampling distribution or otherwise, you want to use your mean. Okay? So we want to find the mean of this thing. The mean is going to be the difference of the population means. So it's mu sub f minus mu sub m. Why am I using that order? Because that's the order that they told me for the distribution. So the mean of the females was 56.4. And I subtract the mean of the males, which was 55.7. And I get a mean of 0.7 inches. So since we're using quantitative data, make sure we're including units, so inches in this case. When I want to talk about the center, or excuse me, the spread, our last thing, we want to be talking about our standard deviation of our distribution. So standard deviation is this formula right here. So I take the standard deviation of the females and I square it over my sample size for my females. Add that to the standard deviation of my males squared over the sample size of my males. So our standard deviation of our females was 2.7. So 2.7 squared over, what was our sample size for our girls? 12. Add that to our standard deviation for our guys. Oh, that's the mean. 3.8. So 3.8 squared over, and the sample size for our boys was 8. Okay? So I would plug all that into my calculator. So here's my calculator. And I'm going to do it all in one step. Just be a little bit careful. My calculator might look a little bit different than yours, but that is okay. Turn on the light there so you can see it. So 2.7 squared over 12 plus 3.8 squared over 8. And we get a standard deviation of about 1.55 inches. So 1.55 inches. We should address the 10% condition. So the reason that we're allowed to do this standard deviation, 10% condition is going to be met because there are more than, 10 times 12 is 120 10-year-old girls, and then there's more than 80 10-year-old boys. Okay, so we have described our distribution. Find the probability of getting a difference in sample means that's less than 0. So we want to find the probability that's less than 0. So because it's normal, we can just go ahead and use our normal CDF. So let's say this instead. We want to find the probability that this difference is less than 0. So we can use normal CDF. If it's going to be less than 0, that means 0 is going to be my lower bound, or excuse me, my upper bound. So some really small number for my lower bound, 0 for my upper bound. Okay, my mean, I can use my mean from up here. And my standard deviation, 1.55. Okay. So in my calculator, I'll go to normal CDF. My calculator asks me to enter things in. So negative, really small number. Upper number is 0. 0.7 is my mean. 1.55 is my standard deviation. And I get 0.325, and then that would round up to an 8. So that's the probability there. An alternative way that I could have done this, instead of going straight to normal CDF, would be to what we call standardize this value. The way I would do that is by finding the z-score, right? That's standardizing it. You take your statistic minus your mean over your standard deviation. So if I did 0 minus 0.7 over 1.55, I would have gotten a z-score of negative 0.45, which then I would have again done my normal CDF, but instead of using these values, I would have used, again, a really small number, my z-score, and then just 0 and 1, because those are my go-to means. And it's still going to give me the same thing, más o menos, more or less. Okay? So lastly, part C. Does the result in part B give us reason to doubt the researcher's stated results? Please explain. Well, let's take a look at this. This probability. 33%. Okay? And what was our claim? Let's go back. I don't remember. Our claim was that the mean of the heights is larger than the mean of the boys is larger than the mean of the girls. So if the mean height of the boys is in fact greater than the mean height of the girls, meaning the difference between females and males would be negative, right? Because this would be a greater number. So a number minus a bigger number gives you a negative number. That's why it's less than 0. If that's true, what we found in part B shows that there's about a 33% chance of getting a difference in sample means that's negative. So this really doesn't give us much reason to doubt the claim, right? This is pretty likely. It's not an unusual value for the probability. So let's just put that into writing. So if the mean heights of the boys is greater than the mean height of the girls, then that would mean the sample mean of the men, or the boys, is greater than the sample mean of the females. AKA, when you subtract the mean of the females minus the mean of the males, you would get a number smaller than 0. It would be negative. Okay. Part B shows that there's about a 33% chance that there's about a 33% chance of getting a difference in sample means that's negative, just due to sampling variability. I'm going to pause this for a second. Sorry, I paused it because it's a little bit quicker if I just write it, and then you can either pause the video here and then copy it so I don't run out of time. I only have 15 minutes. So, this was our very first video. I hope you enjoyed it. Tomorrow in class, you are going to be working on example 2 about the potato chip manufacturer, and then more examples from there and maybe in the homework. Okay? Thanks for joining. Let me know tomorrow in class if you have any questions about sampling distributions for the difference of two means. Have a good night, guys.